Hello students, in this video I am going to do the exercise 2F, which is related with quadratic equations. This exercise is very important from examination point of view. As you are aware that invariably one question is asked from this exercise on the topic quadratic equation in every exam of CA Foundation. Now I am doing the questions of exercise 2F, and I recommend that to learn this concept you are not going to skip this video and the subsequent videos, and I am sure that at the end of this video you will be able to learn the total concept. We are starting with question number 1. If the roots of the equation 2x square plus 8x minus m cube is equal to 0 are equal, then the value of m is, options are -3, -1, 1 and -2. Now we know that the standard quadratic equation is ax square plus bx plus c is equal to 0. And when the roots of this equation are equal, then b square minus 4ac is equal to 0. b square minus 4ac is called discriminant of the equation. Now we calculate the discriminant of this equation and we will put that value as equal to 0 because the roots of the equation are equal. So our equation given is 2x square plus 8x minus m cube is equal to 0. Here a is equal to 2, b is equal to 8 and c is equal to minus m cube. So b square minus 4ac, that is discriminant is 8 square minus 4 into 2 into minus m cube. This is equal to 0, which gives us 64 minus multiplies this minus will be plus. So 8 m cube is equal to 0. This gives us 8 m cube is equal to minus 64, which gives us m cube is equal to minus 64 upon 8, that is minus 8. Therefore m is equal to, we take the cube root both the sides, so m is equal to minus 2. So here option D is correct, that is for m equal to minus 2, this given equation will have equal roots. Now we can see it also by putting m equal to minus 2 here and the roots of the equation are equal. For that I put m equal to minus 2 in the given equation. So 2x square plus 8x minus 2 cube, this is equal to 0. This gives us 2x square plus 8x minus 2 cube is minus 8. So it will be plus 8. This is equal to 0. Divide the whole equation by 2, which gives us x square plus 4x plus 4. This is equal to 0, which gives us, this is x plus 2 whole square. X plus 2 whole square, this is equal to 0, means x plus 2 into x plus 2, this is equal to 0. That is x has two values which are minus 2 and minus 2. That is both the roots of the equation are equal. So value of m should be minus 2. Now we will see question number 2. Another good question from examination point of view. If 2 raised to the power 2x plus 3 minus 3 square into 2 raised to the power x plus 1 is equal to 0, then the values of x are, options are 0, 1, 1, 2, 0, 3 and 0, minus 3. What we do, that equation can be written as 2 raised to the power 2x into 2 raised to the power 3. Because we know that if the base is same, then the powers are added. So 2 raised to the power 2x plus 3 can be written as 2 raised to the power 2x into 2 raised to the power 3 minus 3 square into 2 raised to the power x plus 1. This is equal to 0. Equation can be rewritten in this manner. Now 2 raised to the power x, if I take equal to y, then 2 raised to the power x whole square is equal to y square, which can be written as 2 raised to the power 2x is equal to y square, because this x multiplies this 2 by laws of indices. So 2 raised to the power 2x is our y square. Put this value here. So equation becomes y square into 2 raised to the power 3, which is 8. So 8y square minus 3 raised to the power 2 is 9. So it is 9y, because 2 raised to the power x is y, plus 1 is equal to 0. We obtain a quadratic equation. We have obtained a quadratic equation, the roots of which, that is the value of y, can be found by any of the methods, by perfect square, by factorization method, or using quadratic formula, that is Sridharacharya formula. So I use here the method of factorization. 8 into 1 is 8. Now I want two numbers whose product is 8 and whose sum is 9. Surely these values are 8 and 1, because 8 multiplies 1 is 8, 8 plus 1 is 9. So I split this middle term. This gives me 8y square minus 8y minus y plus 1 is equal to 0. Method of factorization in which we split the middle term. This gives me 8y can be taken common, y minus 1 is there in the bracket, minus taken common, y minus 1 is equal to 0. Y minus 1 can again be taken common into 8y minus 1 is equal to 0, which gives me two values of y. Y is equal to, first is y minus 1 is equal to 0, which gives me y is equal to 1. 8y minus 1 is equal to 0, which gives me y as 1 upon 8. Now what is my y? It is 2 raised to the power x. So 2 raised to the power x is equal to 1. Now 1 can be written 2 raised to the power 0. Any number raised to the power 0 is 1. So I am writing this one as 2 raised to the power 0. Base are same, both the sides it is 2. So powers will also be equal, which gives me x is equal to 0. This value, power x, which is equal to 0. Now y is equal to 1 upon 8 means second value will be 2 raised to the power x is equal to 1 upon 8. This can be written 1 upon 8 is 1 upon 2 raised to the power 3, because 8 is 2 raised to the power 3. So it can be written 2 raised to the power minus 3, because it is 1 upon 2 raised to the power 3. When 2 raised to the power 3 go in the top, the power will be negative. So it is 2 raised to the power minus 3. Again the base is same. So powers will be equal. So I obtain another value of x, which is x equal to minus 3. Two values of x are obtained, 0 and minus 3. So here option D is correct. Now by using options also we can solve this question. How do we solve? We put x is equal to 0. First we put one value of x, which is 0. 0 if I put, so that gives me 2 raised to the power 0 plus 3 means 8. 2 raised to the power 3 is 8 minus 2 raised to the power 0 is 1. So it is 9. 3 raised to the power 2 is 9 plus 1 equal to 0. Means it is true. 9 minus 9 is 0. So x is equal to 0 is my correct answer. Now I put minus 3. Minus 3 gives me 2 raised to the power minus 6 plus 3 means minus 3 plus minus 3 raised to the power 2 is 9 into 2 raised to the power minus 3, which is 1 upon 8 plus 1 is equal to 0. This I obtain. So 1 upon 8 minus 9 upon 8 plus 1 should be equal to 0. This I obtain, which gives me 8 as LCM. 1 minus 9 plus 8. This should be equal to 0. In the numerator we are getting 0. So I obtain 0 equal to 0. That is, my equation is satisfied by x as minus 3. So another value of x will be minus 3. This is satisfied. So this is how I can check also that my answer is correct. So here option D is the correct answer. Now we will see the question number 3. Question number 3 is the value of 4 plus 1 upon 4 plus 1 upon 4 plus 1 upon 4 etc. up to infinity is. These are the 4 options given to us. Now if we see this expression and put this value as equal to x, then x is equal to 4 plus, now this value is again whatever is written here below this 1 as x, because it is going up to infinity. So this value 4 plus 1 upon 4 plus 1 upon 4 plus 1 upon 4, this can be written as x. So I can write this total value x, which is equal to 4 plus 1 upon x. I can write it like this. This gives me x is equal to, x is the LCM here, it is 4x plus 1, cross multiply and transpose gives me x square minus 4x minus 1 equal to 0. This is my quadratic equation which has 2 roots, and those 2 roots can be found since it is cannot be factorized. So I can find it by using quadratic formula. What is quadratic formula? Also called Sridharacharya rule. If the standard equation ax square plus bx plus c is equal to 0 is our quadratic equation, then x is equal to minus b plus minus under root b square minus 4ac upon 2a. This is my standard quadratic formula or Sridharacharya formula. Now here I find a as 1, b as minus 4, c as minus 3. Put these values and find the roots. So x is equal to minus 4 plus minus under root minus 4 square minus 4 into 1 into minus 1 upon 2 into 1. I have put the values of a, b, c, and these will be my 2 values of x. This is equal to 4 plus minus under root minus 4 square is 16 plus this minus and minus multiplies, it will be plus 4 upon 2. That is 4 plus minus under root 20 upon 2. Now under root 20 can be written as under root 4 into 5. Under root 4 is 2. So it will be 2 root 5. So my 2 values of x will be 4 plus minus 2 root 5 upon 2. 2 divides both. It divides 4, it divides 2 root 5. When it divides 4, I obtain 2. Plus minus 2 root 5 divided by 2 is under root 5. So 2 values of x I obtain are 2 plus minus under root 5. With that, I cannot conclude that my option C is correct, because here important point is that this is a sum. This we are adding. 4 I am adding something, then 1 upon 4 I am adding something. So this value cannot be negative. Here it has 2 roots which are 2 plus root 5. Another is 2 minus root 5. Now root 5 is more than 2. So this is my negative value. And a sum cannot have negative value. So this value is required to be rejected. This cannot be the value of x. This cannot be the value of this expression. The expression can have only this value, 2 plus under root 5. And hence our option B here is the correct answer. We cannot conclude that 2 plus minus root 5 is the answer because it is a sum, and sum cannot be negative. When we are adding numbers, it cannot be negative. It has to be a positive value. So we are accepting only this value. This is the only permissible value. The negative one we are rejecting. Here option B is the correct answer. Question number 4. If alpha and beta are the roots of the equation 2x square minus 4x minus 3 is equal to 0, the value of alpha square plus beta square is. Options are 5, 7, 3 and minus 4. Very important question, because in this question we are going to learn many things which will help us in solving many questions of quadratic equation. So let us understand this question very thoroughly. The given equation is 2x square minus 4x minus 3 is equal to 0. This is our given equation. It will have two roots. First root is alpha, second root is beta. We can calculate those roots also. Alpha and beta can be calculated. But here we are not going to calculate. What we do, that we know ax square plus bx plus c is equal to 0. If this is the equation and it has two roots alpha and beta, then sum of the roots alpha plus beta is minus b upon a, and product of the root alpha beta is c upon a. These two formulae we should remember them. We should remember them because these formulae are used invariably in solving many questions. So we should remember these two formulae, that sum of the root alpha plus beta is minus b upon a and product of the root alpha beta is c upon a. And these two formulae we are going to apply here in this question. So alpha plus beta here will be a is 2, b is minus 4, c is minus 3. So it will be minus 4 upon 2, which is equal to 4 upon 2 means 2. And product of the root alpha beta is minus 3 upon 2. Now alpha beta and alpha plus beta we have calculated. Now we are to calculate alpha square plus beta square. So alpha square plus beta square is to be calculated. Now we apply here a trick. What is that trick? That we add 2 alpha beta in this expression and subtract 2 alpha beta. Means this can be written alpha square plus beta square plus 2 alpha beta minus 2 alpha beta. 2 alpha beta I have added and 2 alpha beta I have subtracted. What is the use? Let us understand it. This gives me, now this is alpha plus beta whole square minus 2 times alpha beta. What is the use of it? Use of it is that I have converted this expression in terms of alpha plus beta and alpha beta, which is the value which we know. So I have converted in this expression as alpha plus beta and 2 alpha beta. So this trick is to be applied here, that 2 alpha beta is added and 2 alpha beta is subtracted. This gives me alpha plus beta whole square means 4, 2 square is 4 minus 2 times alpha beta is minus 3 upon 2. I have put these values. This gives me 2 and 2 are cancelled. 4 plus 3 minus multiplies this minus is plus. So 4 plus 3 which is equal to 7. So here option B is the correct answer. So what I recommend is that in such type of questions, we should not calculate the values of alpha and beta, that is by finding the roots and then calculating alpha square plus beta square. Rather than that, we should apply these formulae and solve the questions. Now we will see the next problem.